in China. But then the cost is very expensive. So the reason for this is because metaphysics. Condensed metaphysics actually studies electrons, okay, or interactions between electrons and phonons. Or what is phonon? Phonon is atomic vibration of lattice. So we are studying interaction between electron and electron phonons, and then that's pretty much condensed metaphysics. The difference between us and the rest is that we're not following anyone. Okay, so we always develop new materials that has never been studied or even synthesized. Okay, so this separates us from the rest, and we are leading this year. One of the materials that we're studying is that if you look at the periodic table, it is we study transition metal oxides. Transition metal. There are three roles that transition metal. Transition metal meaning that the electrons. It's those electrons that are coming from this incomplete shell that actually very often act up. So that's the physical properties that we want to study. And so we have three rows of transition metal oxides. And we have 3D transition metal, that is this first row. So that involves copper, manganese, chromium, and all these common metals. And then these materials has been studied for several years. The 5D materials, that is this precious metal. If you look at that, this constant radium, osmium, uranium, carbon, and such. These are the materials that the 15 years ago, 20 years ago, it's hard to find literature in physics. And so no one studied it. And we did. And then it turned out this is gold mine. So then you can engineer something that has zero thermal expansion. That'll be beautiful, right? Because for instance, the watch. Nowadays we use this electric watch, right? But then in the old time, even now, this fancy watch, you still use this mechanical parts to make this fancy watch, right? So then, if you're now sort of say we have those temperatures 80 degrees, but if you're going somewhere that's very cold, and then all these parts, the volume of these parts will be different. And then how do you adjust this? Because then your watch wouldn't be that accurate. The time wouldn't be accurate, right? So imagine that if you make all these parts using materials that has zero thermal expansion, then no matter where you go, no matter how temperature changes, the accuracy is always there. Right? So this has very wide applications. For instance, the telescope in space, right? That's very cool in space. You make this telescope on Earth, put it in space. So then, if you don't address this the thermal expansion, then all this fancy device in space will not function so well, but because of the difference, the volume difference. So imagine that if you can make materials that has this zero thermal expansion, materials that combines with negative thermal expansion and positive thermal expansion together, so you can make materials that has zero thermal expansion. So then, certainly, then you can use this type of materials not only in space but also on Earth. Right? So the video cameras that we're using, iPhone, iPod, and everything, that is directly associated with materials like that.